Hello everyone, welcome back to our YouTube channel. This is Maaz, your very own computer science instructor. In today's class, we are going to be discussing an introduction to the AS 9618 computer science course. We are going to be going through the overview of what's in the course, what we have to learn, the paper pattern, and some of the basics of the chapter number 1. We are going to be discussing all that. Stay tuned and please don't forget subscribing to our YouTube channel. Starting off, when discussing the AS level paper pattern, in A levels, basically you have four main papers. You have P1, then you get P2, then you have P3, and finally you have P4. P1 and P2 are papers you attempt in your AS or first year of A levels, whereas P3 and P4 are papers you appear in A2, which is your second year of A levels. Now, when discussing these contents, it's important to understand that P1 is your theory paper. This is just the general structure, and similarly, P3 is also your theory paper. And both P2 and P4, these are your programming papers. Now, as this course is more specifically about your AS level content, we are going to be ignoring P3 and P4 totally. We are going to be only discussing P1 and P2. Now, both P1 and P2 has 75 marks in total, and the total marks for this AS level syllabus is 150 marks. So you have 75 for P1 and then you get 75 for your P2. Now, starting off, we need to first of all understand the number of contents, what we are going to be studying, and all that. So, for all those who had O-level CS, it's really easy that you guys, it's like really possible for you all to cover the theory part, whereas the programming part is a bit confusing. However, we are going to be making sure using our videos that you guys are fully prepared for your exam papers. The first chapter which we are going to be starting off today is, let's just write the topic, chapter number 1, information representation. Information representation. Please ignore my handwriting, but yeah, information representation. In this chapter, we are going to be studying some of the key contents about how does a computer stores data. It's really an important question, that how does a computer stores data. We are going to be studying about the number systems which a computer uses to store the data. How does it store the data? What type of data does it stores? What type of data does it stores? And finally, what applications or what actions could be made or done on the data? Could be done on the data. So yeah, when we discuss computers, the first thing which I would like to address, considering that majority of the students also have biology in their O levels and they start off taking computer science without having any of the computer science background, because they studied biology in their O levels and they just came up with studying computer science in A levels. This is for them. I have a question for all the students out there. What do you think? How is a computer made? What is in a computer? Well, the answer to this question is that a computer or any of the hardware devices, they are made up of circuits. The electronic circuits. So let's consider making a small circuit. You have a switch up here, switch, all right? And then this is the wire, and we have an electric bulb up here. Now, in order to turn the bulb on, you either have to press the on button, and likewise, if you want to turn it off, you need to press the off button, right? So if you press the on button, what is going to happen? When you press the on button, the current is going to flow, and then there would be light in this lamp, right? And if you press the off button, let's say you press the off button, you're going to lose the lamp, you're going to lose the light. Now, what's the concept behind this? It's really important to understand that computers also operate in a very, very similar manner. You guys have lots, maybe millions of such circuits in maybe even a small component of your computer. Let's say we have a switch which is being used to print A. Like, let's remove this lamp and let's connect a monitor up here. When we turn on the switch, we're gonna get A on the screen, and when we turn off the switch, let's say if we programmed it that way, that if we turn off the switch, we're gonna get B on the screen. Now if I write a set of instructions such as on followed by off followed by on, so when we feed on into the switch, what is going to happen? We said that with an on, A should be printed, and with an off, B should be printed, right? We programmed the main hardware in a manner. Like, it's not necessary on or off means off, but it could be used for some other operations too, right? So if we have this instruction on followed by off followed by on, right? So how are we going to manage this? Well, it's quite easy. Firstly, on. When we feed on into the switch, what is going to happen? We're going to get A up here, right? Done. Then we have off. When we feed off into it, what's going to happen? B is going to get printed. Likewise, when you again feed in on into the computer, what's going to happen? You're again going to get A up here. So in the end, this instruction, let's say this is an instruction. This instruction on, off, and on is going to get us A, B, A on the screen. This is quite of an easy concept which many students who have interest in computer science would already know. But let's say if you don't, no worries, we are here to help you out. Now, once you get this concept, we are going to be now studying a very important concept. Now, computers don't get this on or off functions. As a human, we do understand what on means or what off means. But for a computer totally operates on numbers, right? And those numbers are either 0 or 1. Now, if you have watched any of computer science documentaries or any videos, you would be well aware that you would have maybe seen codes like 0011, 011, 01, or maybe 01011101, and non-CS background students mostly think that it's some sort of hacking. Well, it's not hacking. This is basically the language which a computer understands. And how does it understand that? We write code, programming code, and then there is this app which translates it. Okay, you write the code in Python, Java, any of the programming language, that gets translated into machine code, which is something like this: 01011101. Now this machine code is something which computers only understand, right? Nothing else. Now if we erase all of this, right, let me clear this up. Yeah, coming up back, we had a small issue, but yes. So I was talking about binary. Now I told you how we convert these programming languages into zeros and ones. Now these zeros and ones, they are known as binary. Binary is not a programming language, but it is the language which a computer understands. And binary has only two values. It could either be a 0 or it could be a 1. A 0 is usually used to represent the off function, whereas 1 is usually used to represent the on function. Now this is quite important because if we convert the same instruction on, off, and on into the binary form, we get the code as something like on would be 1 followed by 0 followed by 1. Therefore, you get your binary instruction for the same operation as 101. Now, if we had programmed the hardware in a way like the previous instruction on, off, and like an on represents a A and off represents a B, we could also say that if a 1 is going to represent an A and a 0 is going to represent a B, right? You get that, right? So if you have this code 101011, and we feed this data into this program. Remember, binary always works from right to left, right to left. This is your right side and this is your left side. Okay, right to left. So what data are we going to get up here? Just think for a minute. We have 1 first, so we're going to get A followed by again A, then a B, then A, then B, and then A. So this is the code you get on your screen. Now computer doesn't get this on and off, it gets this binary. So this is a small introduction about what binary is and what you guys need to understand about binary in computer science. Now binary isn't tested in this manner that they just give you an on or off statement, because this is quite easy, or maybe just the basics which I want to clarify. Now coming up to the stuff mentioned in the book, let's make some area for the content. And yeah, so binary in the book, it has been mentioned that binary is a base 2 number system, is a base 2 number system. What do we mean by base 2? By base 2, like we are going to be studying it later on, that we have a base 2, then we have one known as base 10 number system, and then a base 16 number system. There are 3 basically number systems which are used to represent data within a computer. Now binary is the first one which we are going to be studying. Now by base 2, we basically mean that binary number system only has 2 possible values. 2 possible values. You see, we get 2 from here. 2 possible values. And those 2 possible values are either 0 or 1. Now this is quite easy to understand that binary is a base 2 number system and it has zeros and ones as its only possible values. But now we need to see what type of questions could the examiner test us on our CI examination. It's really important because you see, you could be given a question such as, let's make a question up here. Now this question is really easy level, but yeah, they're going to give you something like 0 1 1 0 1 0 1 0 1 1, let's say, and then they're going to tell you convert into integers. Now you need to convert this computer's language into human language, which would be something like a number. You're going to get some integer up here such as, let's say, 75. But now we need to understand, how did you get this 75 from this code? For this, you need to understand one basic concept, that is that in every binary situation, binary values always have some sort of weightages assigned to it. Now, what do I mean by weightage? By weightage, I mean that before talking about weightage, let's discuss one other thing, because then it would be very, very easy for you. Imagine you have something to note down. Let's say you're making notes for the same computer science topic. Now, where are you making those notes? You are making those in some sort of register, right? Or on your iPad or some sort of electronic device where you are storing those notes. And once you are done with the notes, you close your folder or save that file in a folder. Likewise, the binary codes which you write on your computer, they're also stored in a specific folder. They are stored in a folder. In the world of computer science, we call that folder as registers. It's quite important. Registers. Registers are specific places where you can store your binary codes, right? This is quite easy to understand. You could just call it as folders or maybe even racks where you could store your code or stuff like that. But yeah, we call it registers, and you should be well aware of what registers are. Now, registers could store either registers could be of several types. You could have 8-bit register. These are the size, right? And then you could have a 12-bit register, and then a 16-bit, and so on. Next would be 32 and then 64. But yeah, in your course, you are going to be getting tested on 12 and 8 majority of the times, and maybe very rarely they test you on the 16-bit. But yeah, there is a possibility. But now, you need to understand, what do we mean by bits? Consider the following binary code. This specific single digit this one digit, this is known as bit, right? This one digit is called as a bit. Now this is one bit, this is the second bit. Let's highlight it, that way it's much better. This is the second bit, this is the third bit, this is the fourth, fifth, sixth, seventh, and eighth bit. So what do we get up here? We have an 8-bit binary code. And to store this 8-bit binary code, we need an 8-bit register. An 8-bit register would be a slab like this, which is going to have 8 portions: 3, 4, 5, 6, 7, and 8. And we're going to store this code in here like 011 00110. You get this, right? We have stored this code. Now, if we had some extra numbers, let's say 1111, then this would have been 9th bit, 10th, 11th, and 12th bit, and so we would have been required to use a 12-bit register. And likewise, if we had 16 bits, then we had to use a 16-bit register. Now, one common thing, something maybe even new for the A-level content, which majority of the students aren't aware, is that they very well know that this is an 8-bit register, right? Many students usually know that this is an 8-bit register, but they don't know one other thing. 8-bit register is equal to 1 byte, right? This is something students study at O levels, but then there is something new in this in the AS content, and that is if you have 4 bits, or if you split this into 2 equal parts, for this and for this is equal to 1 nibble, NIBBLE. Now sometimes they might ask you what does a nibble mean, and you need to tell that a nibble is a specific type of register where you could only store 4 of the bits, right? You get only 4 bits. Not a specific type of register, but when you combine 4 bits together, that is known as a nibble, and 2 nibbles make 8 bits. And 8 bits equals to 1 byte, and then we get the conversion, like if we have 1000 bytes, that's equal to 1 kilobyte, and then 1000 kilobyte, sorry if it's becoming messy, but we get 1 MB, a megabyte, right? And then likewise if we have 1000 MB, that's equal to 1 gigabyte, 1 GB, and so we go along the way up to terabytes and I believe petabytes or petabytes, I'm not sure, but yeah, one of those. PB, it's known as PB. Yeah. Now we were talking about how do we convert a specific code into integer value, and with that we would be ending the class once we are done with that. But yeah, let's write the code once again. We understood the concept of registers, right? Now if we make a register up here, let's write some code. 11, not up here, let's do it down here. 01001101. Okay, let's make 8 sections. 1, 2, 3, 4, 5, 6, 7, and 8. Now we need to understand that each of the bits have a specific weightage assigned to it, and that weightage is being calculated by its position. Now how do we know the position? Well, in a register you all need to understand that we start from the most right hand side in binary and we move towards left side. Like when we read it, we do it the opposite way, 0100, but when we are using it for calculations, we always go from right to left. And so we need to firstly find what are the positions up here. Now one thing, an important tip, a very important tip, in CS everything starts from 0 and not 1. This is super important because many of the students, including me myself, sometimes make this mistake that we start this from 1. Well, it's not from 1. This is a big mistake many of the students sometimes make, and this starts from 0. Then we have this as 1, this is position 2, this is position 3, this is 4, this is 5, this is 6, and this is position 7. So we count this as also a position, an individual position. So 1, 2, 3, 4, 5, 6, 7, 8, total 8 positions or 8 bits. Now to calculate the weightage, there is this one equation for the newbies. Okay, this is for those who are new into the world of computer science, but for those who do know the concept and have studied it, or later on, even if you are new to it, you're going to memorize these weightages on your own once you're done with a bit of questions. The formula to that is 2 raised to power of position. 2 raised to power of position. 2 comes from the fact that binary is base 2. If it was, let's say, base 10, then we would have used the formula 10 raised to the power of position. And so, using this, we are going to be calculating the weightage of each of the position. Let's erase this part. Yeah, we don't need this. And let's conduct all these questions up here. So 2 raised to power 0 is 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4, 2 raised to power 3 is 8, 2 raised to power 4 is 16, and then 2 raised to power 5 is 32, 2 raised to power 6 is 32, 64, 2 raised to power 7 is 128. Right, now let's remove these position and write the weightages. So we get it as 1, 2, 4, 8, 16, 32, 64, 128. It's not that I've memorized these weightages, but it's basically that I have written or made such registers so many times for my questions that I've memorized everything 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and so on. And so with a couple of questions, you all are also going to memorize it the same way. Now, how do we convert this specific code into integer values? Well, really simple. The thing which we are going to be using right now is that wait, let's get some space and then let's get to the main thing. Yeah, so now what we are going to be doing is that there isn't any specific formulas in computer science. Okay, we're going to be looking at the places where we have ones, 1, 1, 1, 1. We are going to be ignoring all the zeros and considering all the ones. It's really important. And once you have once you look at these 1, 1, 1, 1, 1, we're going to be adding up, add the weightages, the weights of each position where we have a 1, Now this is important because you see, when we add the weightage, we get the integer form of the binary. Let's say we have 1 plus then 4 plus 8 then plus 64. Let's add this up. 64 plus 4, 68. 68 plus 8 would be 68 to 70, 76 plus 1, 77. And you get your answer as 77. This means that this code 01001101 is 77 in your integer form. And in the later on classes, we are also going to be studying how you are going to be converting this 77 back into your 01000101. But that is all for today. I hope the class was helpful and you guys understood how we converted, how basically what computer science AS level course is all about, and what's the basic binary concept, and how do we calculate these values. And in the later on classes, we are going to be discussing other parts, important parts of the course too. Till then, don't forget to subscribe. Take care, and yeah, best of luck for your examinations.